Hello everyone. So this is day 3 of watching Jalla code. This is gonna be the day 2 of the the Go series. Yes, this is gonna be day 2 of the Go series. Today we're going to use Go by example. So yeah, let's I would say let's go. Okay, let's start. Let's be foreign. Let's grind. That's what we see these days. I think I would suggest everyone follows along with the Go by Example website. It's very, very simple. Gobyexample.com. I was thinking of what resource I could use, and I came across this. It covers basically everything: hello world, values, variables, constants. So by the end of this, we should have a basic understanding of Go, or we should have at least by the end of the whole Go by example something. So let's begin. But first, I'd say we should recap what we did in the last video. So last time we just went over basic Go. We imported the main package. Okay, we didn't import the main package. We defined a main package. A main package is this whole thing. Everything in this file is part of the main package. We imported the formats module. We also learned how to import foreign code. The formats module was used to bring things to the console, and we learned that Go code starts from the main function. So actually, I didn't learn anything on Go outside of the initial video we did because I want to actually learn at least learn Go on the camera. So one thing I learned, I said that semicolons are not compulsory, so I use them because I'm used to them. But I did find out that the Go community frowns on using semicolons. So using semicolons in Go is considered bad Go, which I feel like is crazy. But I guess I won't stop using semicolons. It doesn't change anything. I will still use my semicolons. It's okay. So let's begin. Let's go by example. Are you all excited? Because I know I certainly am. So let's see how it works. I won't do hello world again because we just did that in our last video. So now let's talk about values. Or we can read what's here. So the Go by example website. So Go is an open source programming language designed for building scalable, secure, and reliable software. Please read the official documentation to learn more. We'll also be going through the code documentation while we actually do this whole Go learning journey. But I want Go by example to be our primary source of like seeing examples and learning Go. Then we go to the documentation where we want verification on certain things. Yeah, examples here are up to date unless stated otherwise. Okay. So I assume everyone has Go installed, but let's go over if you don't. If you don't have Go installed, you could do so by doing, if you're using like a double SL, or at least in a Linux system, you could do double SL. Sorry, you could do sudo apt install golang -go. I think this is the install command if you don't have Go installed, but I assume everyone has Go installed. Doing shift, using the shift key plus one of the arrow keys here causes D to show up in the command terminal, but that's by the way. Okay, so yeah, today's video is going to be 35 minutes long. I have a 35 minutes countdown about to start, and I'll probably speed the main video up by like 1.2, so it won't feel like 35 minutes. Maybe you'll feel like 30 minutes or thereabout, but I just started the counter, so let's learn. Oh. Go by example. So values. Okay. Go by example values. Go has various value types, including strings, integers, floats, booleans, etc. Okay, so they have the standard types that we are all used to if this is not your first time programming. If it is your first time programming, we'll learn everything together. Strings are like alphabets. They're enclosed with quotes. Integers are like numbers. Floats are like decimal numbers. Booleans are true or false. Okay. So here's an example. Once again, they defined the main package, which is everything in this code block. They imported the format macro so they could print things to the screen. And then they defined a main function. So print line go plus lang. This is what's called concatenation. So I guess Go concatenate strings as well. They tried out their addition, more math, then they did some Boolean logic. format print line true and false. Assume and is the AND operation for, okay, we'll get to that, but I assume is the AND operation for false. Okay, let's copy this code. Let's copy this code. Then we'll make our way back to the VS Code sim. Okay. So I won't make another Go directory or anything because I don't know how that works yet. So there's no point. Let's just clear all what we have here. Control A to get everything and delete. So once again, get ourselves a package, pck package main. Then we use a semicolon because I prefer to use semicolons. You guys don't have to use semicolons now. Then we import the format macro fmt so that we can print stuff to the standard output. Then we define our main function. Yeah, we define our main function. Yeah, so we define our main function. Define main function. Okay. What do I do here? We want to try out strings and concatenation first. So strings are like basically words or alphabet. Strings are technically alphanumeric, and they're usually enclosed in quotes. So things like, for example, this would be a string. I am a boy. It's a full sentence and it's enclosed in double quotes. I don't know how they use single quotes, because I know some languages like JavaScript you can use double or single quotes for your strings. But in Go, for now, from what we saw in the previous page, they only use double quotes. So this is an example of a string. A string is anything enclosed in double quotes. Basically, that's the basic definition of a string. So we could print a string to the console by doing fmt print line by using the print line macro. The print line macro prints to the standard output, then prints a new line escape character, prints to the standard output, and prints a new line. That way, when you print to the console again, you print in a new line. I'll show you how it works with and without. But for example, see, as I put quotes now, whatever I'm going to write in these quotes are strings. For example, once again, I am a boy. Yes, and if we run this, if we run this code by doing go run. Oh, no, go. Okay, sorry. CD, hello. We have to go to the hello directory. Now we try that again. Go run. Yeah, prints the I am a boy and goes to a new line, then prints my terminal thing. If we didn't use the print line, maybe fmt has a print macro, which it should. If you have print line, you should have print, and it does have print. So here it will print without going to a new line. So you see the difference. If we print I am a boy, the string again, then we run it. Go run. Okay, see, now it prints it but doesn't go to a new line, so it interferes with this. That's why most times people use print line. So yeah, we'll be using print line unless we don't have to. Shift home. Yeah, most likely we'll be using print line. So this is a string. It's enclosed in double quotes. So now we know basically what strings are. Now we want to learn concatenation, because Go strings allow concatenation as well. So when we see concatenation, what I know that means is concatenation. Basically, you are just adding two strings. You're just adding two strings. And both strings that you're adding have to be in quotes. You can add hello, then plus, because plus is the operator for concatenation. So you can add hello plus world. That's hello world. That the output of this would then be the single string hello world. So basically, concatenation helps us to build strings. So if we printed two separate things in the console, fmt the print line, I wonder. Hello? Because I added this additional space because if we don't do so, you won't see space there. But let's say we don't add it. Hello plus world. I wonder if this will work because I'm pretty sure in JavaScript you can't do hello plus world directly like this, but this is a different language. So let's see if it works. If it doesn't work, we'll get an error. Then we'll learn from the error. So go run. Okay, it works, but see, because I didn't put a space, we have hello and world together. We have hello and world together. We don't have them as separate things. But I'm curious as to why this works. Usually I feel like it shouldn't because we didn't assign it to a variable. So this is strange for me coming from a different language. But we know it works. Now, I'll check the documentation as to why it works in a minute. Now I'm going to add a space and we're going to try this again. And this time we should print hello world the right way. So this is basically concatenation. Strings are stuff enclosed in quotes. Yeah. Strings are stuff enclosed in quotes. And we can concatenate strings in Go. Concatenation is basically building up strings. And technically you can also do them straight from the print line function, which is great, I guess, but it's strange to me. Now I want us to actually look at the description of the print line function. So we'd have to check the Go documentation. So let's go there. Oh my god. Go to make anything. Okay. So now I can go look into the Go documentation. Okay. Not installing Go. I want to search for something. I want to search for something. How do we search for stuff here? Learn. Usually, I would see documentations have some sort of search engine and we can use. How do I search for? Okay, I could just put it directly in the search engine. Explain the go fnc.print line function. FNCTIY. We know it prints stuff to the console. More. I want to understand more. Give me a sec. Why can't we just get... Okay. Let's see this. The built-in format package provides many useful functions which are used to print to the console or format to a string. Yes. So one thing I can say now that I've seen this is that we could actually say that doing hello plus world is actually formatting the string in a way, especially being able to do it with the print line function. You are formatting the string, you are changing how both strings look, making it one string. So I guess because this is a format module, it actually, I think that maybe that's one of the reasons that allows us to do hello plus world directly, because I'm pretty sure this doesn't work in JavaScript. Oh yeah. So let's go back and see. Okay, fmt.println is the basic print function golang has to offer. It prints the values given to it separated by commas and adds a new line to them. Hey, this is what I was expecting, for us to pass separate things and for it to work. fmt.println prints hello. Multiple arguments of different types can be given separated by commas. Prints hello to 893. Yes, this is how I expected the println function to work. But it can do concatenation inside. I think I may understand why, but if I don't get an exact answer, I will just be speculating. Okay. We can ask it a different question. Why does fmt.print line hello plus world work? Okay, let's look at this from Stack Overflow. In Go, both fmt.println and println are used to print output to the console, but they have significant differences in their usage, functionality, and intended purpose. fmt.println is part of the format package, which is a standard library in Go. It is designed for formatting. Okay, it's designed for formatted IO and it is suitable for production code. Yes, I understand this. I think because I'm not finding what I'm looking for, I'm going to ask AI, unfortunately, because I still want to ask. Let's ask Grok. Usually I use ChatGPT, but whatever. And I don't think this counts as vibe coding because it's not vibe coding. I would never say this is vibe coding. Okay, yes. What do you want to know? Why does... Can I close this? Whatever. Why does print line... fnt.print line hello plus world work? Why does the addition work in the function? I wouldn't call this addition, rather it's concatenation. But let's put addition, because I feel like I don't understand why it's called AJCI. Yeah, that's the spelling of addition. Why does FNZ? Okay, in legal extraction works because the plus operator is used for string concatenation, which we know when applied to string operands. Here is a concise explanation. String concatenation with plus. In Go, the plus operator is overloaded to concatenate two strings. When you write hello plus world, Go combine these two strings literally to a single string hello world. Time do that compile time, making it efficient. Okay, why it works? fmt.println function accepts a variable number of arguments of any type using the interface type in Go. We'll learn that in the future. The concatenated string hello world is a single string value, which is a valid argument for println. Yes, okay, I think I understand. Technical details. String concatenation with plus creating a string is trained in Go and strings like hello world. Their compiler may optimize the concatenation by combining them into a single literal during compilation. Okay, I feel like I understand why it works. Yes, I understand why it works. And let me explain what I think I understand. Okay, so it's not the hello plus world works in that sense. It works in that sense because before it actually hits the print line function, it gets concatenated. Make it make sense. After it's concatenated to hello world, and then it enters, it becomes an argument for the print line function. Print line function. That's why it works. That's why it works. This first becomes an actual string. It first becomes the output, which is this. Then it's passed to the print line function and printed to the standard output, which makes sense. I hope I didn't waste our time by doing that. I just wanted to understand because I felt like I've not seen that before. I think you haven't seen before should get researched. Okay, so we've seen strings and string concatenation. The same works for numbers and floats and Boolean values. Okay, we'll try all these. I'm just gonna copy these and paste them. Then we'll speak about them there. I don't want to copy, whatever. Let's just copy these and paste them into our code. Okay. Now let's talk about the rest. So let's get rid of this. Okay, now let's go. So these are integers and floats. This one, we're adding 2 integers. Yes. And first of all, like, since we know how this worked, we also know how this kind of works. The addition is not done in the println function. This is evaluated first. So basically it looks like the arguments passed to functions. So I guess we can come to a conclusion. Arguments passed to functions, if they contain operators like plus, it is addition or subtraction, minus, are evaluated before they are passed to their functions. Passed to their call functions. This is good to know, clarify some things. So this is evaluated as true before it's then passed and printed out. Now, there's no concatenation that happens here. Remember when we read the description of the print line function, it's printing two separate things. It said it can be overloaded. It can take multiple values. That's why you see this spread. This in JavaScript, this is called the spread operator. It means that the function can take many things. So that's why we have it here. So the function can take many things, all separated by commas. So the first thing it does, it prints a string, which is this. Then it evaluates 1 plus 1 and prints that, which the answer for 1 plus 1 is 2. So that gets printed. So we have 1 plus 1 equals 2. They are separate, they are not concatenated. But 1 plus 1, the integers are evaluated. And integers are like, basically, you can think of them as whole numbers. They are full, they don't have fractional parts. It's 0.0. There's nothing else at the end. So they are basically, we call them whole numbers. And these are floats, these ones. They are floats. Floats are, here we are adding, no, we're not adding, we are dividing. Two floats. This also tells us that this is the forward slash is the division operator. The forward slash is the division operator. Yeah. So we are dividing 7.0, which is a float. A float is a number with a fractional part. Even if the fraction is 0.0 here, it still exists. So if a number has like a decimal point after it with some additional value, then you're most likely you're dealing with a float. You're dealing with a float. If not, you are dealing with a decimal value. So these values are floats. 7.0 divided by, because we know that the forward slash is this forward slash is the division operator. 7.0 divided by 3.0. So we are dividing two floats. So once again, this is evaluated first. Then the answer is passed to the function, and the function prints the two arguments it was passed. This can be this one, because it's evaluated into one answer, can be seen as one value, and this is another value. So they are printed to the console. Then here we're dealing with Boolean values. Boolean values. Booleans are true or false values. I'm sure if you did some form of high school, because I know I did some form of high school, so even without knowing any programming, you should be familiar with what's true and what's false. So here, this is called the AND operator, I believe. Depending on how Go works, this is most likely the AND operator. And will only give us a result that is true if both values are true. So for true and false, we'll get false. But if we did true and true, we should get true. If we did false and false, we get false. Yeah, this is the same as the AND operator in JavaScript. So yeah, so for this true and false, the output should be false, because it's a logical something, a logical operation. This is the OR operation. The OR operand. This means or true. So this is basically true or false. In Go, it seems like the OR command or operator, the OR operator in Go is two pipes, or are two pipes. Yeah, it's the same as the one in JavaScript, so just two pipes. So this means this is asking us for true or false. The true operator works by, the OR operator will return true if at least one of them is true. So the result here would be true. If you did true or true, it would be true. It would only be false when you have no false argument, when you have no true arguments. So true or false, false or false would give us most likely false, because the false thing is only true. The false operator only uses true when you have at least one true argument. Then here, what they're doing is called negation, where you're negating. They're negating stuff, or inverting. The inverse of true is false. And the exclamation mark is the inverse operator. So I guess we can print all this stuff to the console by running the code. But let me clear my terminal and do it. Go run. Yeah, so I am a boy. 1 plus 1 is 2. That's for this, which is, oh, here's 1 plus 1 is 2. 7 divided by 3 is 2.333. Yeah, there's probably a way to round this up, but we don't know how to do that yet, Tingo. We'll see it in the future. Then, yes, true and false is, of course, false. True or false is true. And the negation of true, or the inverse of true, is false. So we've covered all the basic types. Basic. I think these are called, oh, there's a way we say this in programming. I've forgotten. Is it? But I know they're not called basic. They're called primitives. Yes, these are the primitives. Primitives. Primitive types of Go. Yeah, and strings in Go can be concatenated. Yeah, so, I mean, we've got like 8 minutes left in the recording time. So I guess we can keep going. So, but for now, we've learned all the primitive types of Go. So I will just list them out. We've got strings, which can be concatenated. We've got strings. We've got integers, which are basically whole numbers. The integers we have here are base 10 whole numbers, but you know that we can have whole numbers in binary as well. I guess at least we should be able to. We can have whole numbers in binary, whole numbers in octadecimal, which is base 8. We can have it octadecimal as well. So we can have I actually don't know about this. We'll check before the end of this video. But it should, because they are number systems, they should definitely have fractions. If not, it means we'll just throw away unequal divisions. So then we looked at floats, which are numbers with decimal bits. Then we finally, the last of their primitive types on that page was Booleans. I can't spell Booleans, so I'll just put bool, which are basically true or false. We also learned the basic operations that go with them, like addition for concatenating strings, addition for whole numbers. Basically, what you can do in regular math with a pen and a paper, you can do them in a program, unless you don't know how. Then that's a different case. Okay, so now let's go back to our browser. Next example, variables. I think I will say we should stop here and just recap and do things with the code, because I feel like variables should get their own videos, because Go have this unique syntax that I've never seen anywhere when assigning variables. Apparently it's a shorthand for declaring and initializing a variable. So I will leave this for tomorrow, then we can check, because I said something down to validate. Oh no, I said something I want to validate. I said that other numbers of other base can have decimals. I don't know this, and I don't want to say rubbish, but they should technically, because it makes sense for them to be able to have such a thing. So let's actually look it up, because I feel like they should have. If they don't have, I would be disappointed. Thank you. Do numbers of other bases have fractions? They should definitely, but I've never actually used a fraction of another base, set base 10, but they should. Yeah, fractions work the same in all bases. The denominator and denominator can be represented in any base like, however, the representations of fractions in different bases can vary. So something like octadecimal. Yes, in fact, now I feel like the question I in fact doubted it seems stupid, but it makes sense. I'm glad we verified. Let's talk to Grok about it, because this is where he used AI. I don't want to actually go searching the internet for things like that. I'm not that energetic. So how do you use fractions in other bases? Using fractions in other bases is similar to using fractions in base 10, but the digit values are interpreted in, the digit and places values are interpreted in the given base. Okay, here's a clear explanation of how fractions work in different bases. In base 10, a fraction number like 0.375 is represented as 0.375 base 10, 3 to the negative 1 plus 7 to the negative 2 plus 5 to the negative 3. Yeah, which makes sense. Each digit after the decimal point represents a negative power of 10. Yes. In general base b, a fraction. Okay, in a general base b, so now they made the base general. A fractional number is written with a radix point, the equivalent of a decimal point. Okay, a radix point. Okay, so in a general base, so let's say any base including base 10, a fractional number is written with a radix point, which is the equivalent of a decimal point, and digits in the range 0, -1 to b minus 1. Okay, each digit to the right, to the radix point, represents a negative power of the base. For example, in base b, a number like 0.d1, d2, d3, and is... Okay, it seems to be the same general thing where they are digits in base b. Converting fractions between bases. To work with fractions in another base, to plain need to convert a fraction from base 10 to another base, e.g. binary, hexadecimal. Okay. To convert a decimal fraction, e.g. 0.375 in base 10 to another base b, multiply and extract. Okay, there are methods to doing this. For example, convert. Okay, this is how there's a method called multiply and extract. So to multiply, first we multiply the fractional part by the target base b, take the integer part of the result as the next digit, repeat with the remaining fractional part until the fraction becomes 0 or you reach the desired. Okay, let's state it again. Multiply the fractional parts by the target base b, take the integer part of the result as the next digit, repeat with the remaining fractional part until the fraction becomes 0 or you reach the desired precision. Okay, so let's look at an example. Convert 0.375 from base 10 to base 2. Base 2 is binary. 0.375 times 2 equals to 0.75. Okay, so first they multiplied the whole thing by 2. The integer part is 0, fractional part is 0.7. Okay, then they multiply 0.75 by 2 again, which is 1.5. The integer part is 1 and the fractional part is 0.5. They multiplied 0.5 by 2. Okay, I see what you're doing. You multiply the number you want to convert to another base. For example, this is a base 10 decimal, so we want to convert to base 2, so we're multiplying by 2. Then we get the integer part, and the result is 0.75. We split that into an integer part and a fractional part. Then we take this fractional part again and multiply it by 2. Then we split the result into integer part and fractional part. Take the fractional part again, multiply by 2, and split into once more. We do this until we've got the fractional parts to 0, then we stop. So the binary fraction is 0.0112. So 0.0112. They took all the integer numbers. Okay, so they took all the integer parts from the ground up, which is 1, 1, and 0. So this was the end result. Okay, so that's the timer for the video. So yeah, I guess this brings us to the end of the video. So I guess we'll do a quick recap of what we learned today. Okay, VS Code saying tab, excuse me, we're going to VS Code. Yes. So yeah, once again, we've done a recap already. We learned primitive types in Go, all the basic primitive types and some of the operations. So yeah, this brings us to the end of the video. If you enjoyed the video, I would ask that you leave a like, subscribe, and yeah, see you in our next video. Thank you for your time. I appreciate it.